Hi, everyone. A quick announcement before we get into today's recording, and that is our office, Fame Architecture and Design, is hiring. The two positions we're looking to fill are an intermediate architect and an intermediate interior architect or interior designer. To qualify, you must be located in Los Angeles and have 5 to 8 years of experience in custom modern residences, which is what we do. The software that we use in our office is SketchUp, Enscape, ArchiCAD, and the Adobe Creative Suite. If you don't know ArchiCAD, it's not a big deal. Please still apply, and you will learn it in our office. We mainly want to hire talented designers who are hardworking. We are a full architecture and interiors practice, which means that you will be exposed to or do site planning, architecture, interior design, structural coordination, MVP coordination, permitting, renderings, client presentations, construction documents, and construction administration. So if you're interested in working with us, please submit your materials to hiring@famearchitects.com, and that's our website and where you can find out more about us. This is the second studio hosted by the Architecture and Design Office Fame. My name is David Layton. With me is Marina Borderonay. The two of us are architects, partners at the office, and of course, hosts of the show. Today, our guest is Jaume Soleil.
Jaume is an acoustician, and he's also the founder of SoundArts Consulting in New York City.
With Jaume, we talk about his story and also how he creates great acoustics or excellent or perfect acoustics for halls and theaters. So some of the conversation is quite technical. He discusses, broadly speaking, the different approaches that he's been exposed to and utilizes in his profession, the scientific approach and the subjective approach, and blending the two. We also talk about multi-purpose rooms at the very end and the challenges of that. We discussed the quality of sound and what you hear as an audience member versus a performer on stage, and what it means to work with an architect throughout some of these projects.
Yep.
Sponsors.
Spreadsheets can't bring your designs to life, but Programma can. Say hello to a bespoke integrated software suite built by and for experienced architecture and design professionals. Use your Pinterest image library to build collaborative mood boards, then turn them into shared online presentations with a click using Programma's pinboards. Use the Programma Web Clipper to build a centralized specification library for your studio. Share always up-to-date specifications and product schedules with clients, trades, and colleagues by generating beautiful, branded, live links and client dashboards. Programma's clean, minimal interface allows your work to shine. Start for free and save 25% on annual plans at programma.design/second studio.
This is the second studio with myself, Marina, and our guest, Jaume. Here we go.
Everything just collapsing in front of my eyes and realizing it's like, okay, maybe you don't know everything. My name is Jaume. Jaume is James in Catalan. I grew up in Catalonia in the Pyrenees in a small town north of Barcelona. It's about 70 miles north, very close to the border with France. And yeah, as a kid, I studied music. I played piano. I was singing in a choir as well. So there was like a connection with music at that time. I didn't know anything about acoustics at the time. And when I was 18, I moved to Barcelona and started my engineering studies at the Polytechnical University of Catalonia. And I always thought that music and engineering were basically two different things. And music was kind of a hobby that I was doing on the side, and the engineering would be my job. And when I was at the end of the engineering in Barcelona used to be like 5 years long, and then you had like an extra year that you did the thesis. And in the last year of the university, we had different specialties, and one was about acoustics, right? And I was like, it was like love at first sight. It's like, wow, this is what I want to do. It's like, I couldn't believe it. It combines my love for math, physics, and also my love for music. And it's like, I didn't know that there was that intersection, right? So at that point, everything became super clear and super simple. It was that moment of clarity. It's like, wow, yeah, I know what I want to do. So
Did you think that you'd ever pursue music as a profession though, before going into engineering?
Not really. I mean, it was something that my parents wanted me to do, to study music, but it was always considered like a thing that you did on the side, not to study to become a professional musician. It was like something that was important to do, but the idea was, okay, you'll go to the university and you'll study something that then will become your your career in the future, right? So,
right. Wait, so what was it was a 6-year program. Is that in total 6 years?
Yeah, it's 5 years, and then you had like an additional year that you did like this thesis or this project that was like a full year to complete, and then you had like you had to present and defend that project to your group of professors that were asking you questions, and then finally you got your degree. So actually, when I got to the last year of the university and I found what I wanted to do, I started working actually with a professor of acoustics at the university, and it took a little bit longer than a year to finish my project because I was just doing what I really loved, and at that point the project felt that it was really not important to do the thesis. But anyway, eventually I finalized my thesis and I presented and I got my degree. But yeah, I mean, as soon as I found what I wanted to do, it's like, okay, I was like, I really want to do this right away.
Yeah.
So did you have to stay in school after that 6 year to study more the acoustics, or like how does that work?
You could, but actually, I mean, I was very lucky. I worked with this professor for about half a year, and after that, I was lucky enough to start working with one of the lead acousticians in Europe. His name was Jaume, and he was based in Barcelona, and he was doing all the top concert halls and opera houses in Spain, in Catalonia, in Southern Europe, and I started working with him, and he was my mentor. It was a very small office. It was basically 3 consultants there. He was the principal, and then I was like just working with him all the time and just going to all these fantastic projects and meeting with these great architects, and that's basically how I really learned the profession, like with this great mentor that's just shown me his approach to acoustics, right? After that, I've worked with other acousticians that have very different approaches, and that has been interesting. But yeah, I worked with Jaume for 5 years, and that was kind of my master's in acoustics, right?
Right. One of the things I was curious though is, so in the United States, when you go and study engineering in college as an undergraduate student, it's usually focused on something, at least in my experience witnessing it indirectly, like it's mechanical engineering, civil engineering, structural engineering, like whatever else. So those 5 years, was it specific to one of those types of engineering, or was it just broad? Because it seems to me that like also acoustics, I guess acoustical engineering, or however it would be described, is also very, 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 very specific. So is the first 5 years like a generic engineering education?
It has changed a lot since I did go to the university. That was the 1990s. And now the programs have become more similar to the US. But at that time, when I studied, it was very broad. The idea was like it was very challenging. It was technically really very high level. But they gave you like a very broad vision of what was possible. And then they gave you like a really hard time to pass the exams, and the idea was like, okay, after you're done, you'll be able to do whatever you want, because I mean, if you were able to complete this thing, then you'll be fine, right? So
it sounds really difficult, because again, it's if you're having to become somewhat of an expert or pass these exams in different types of engineering, I feel like that would be very difficult. It sounds like it was not easy.
Yeah, my university was focusing mostly in electronics, telecommunications, but we were doing from the component of electronics rather spatial satellites and acoustics. Wow. So you can imagine it's like all over the place, right? It's like
yeah. So you can fix a car too, probably, right?
No, we didn't do that part, but yeah, probably I can figure it out.
Yeah. Yeah, it's fascinating. So maybe for listeners who don't know anything about this kind of field, what does an acoustician do?
So acoustical consultants, we focus on the sound of spaces, right? And sometimes when people think about acoustical consultants, they think about sound systems and loudspeakers. I mean, I specialize on the architectural aspect. In the past, I used to do sound system designs, but now I just focus exclusively on the architectural acoustic aspect. So that refers materials, the geometries of the spaces, and how do you design a space so it provides the best acoustics for whatever you want to do in that space, right?
Understood. So you mentioned working with a number of different acoustic consultants, acousticians. I don't know what the word would be.
Yes, all of the above, acoustical consultants,
okay.
acousticians, yes.
Okay. And their approaches being different. What does that mean? Like, is one more scientific and numbers-based versus another?
Yes. Yeah, that's absolutely correct. I mean, when I was in Barcelona working with Higini Arau, he was a doctor in physics, right? So he really didn't have a background in music. And in general, in Europe, it's kind of this approach is very scientific. We used to model everything, right? We had these computer models or even scale models of halls that we tested every single aspect of the sound inside the room. We calculated the isolation, the noise going through the mechanical system, but everything was scientific and a calculation and a number, right? And that was very comfortable. I mean, you're designing a space, a concert hall, and you know that the reverberation time, that's the time that it takes for the sound to disappear when you start playing a note. So in a concert hall, you usually want that to be about 2 seconds, right? So you do a calculation and you get to 1.98 or 2.05, you know that you're pretty close and that's going to be very good, right? So you feel very comfortable with numbers. And then when you complete the hall, you go there with microphones and loudspeakers and you measure everything and you find out if you got the 1.98 or the 2.05, but everything is very scientific. When I moved to the States, that was 2001, I thought that it would be even more scientific in the States, but I landed in a company that had like a very different approach, that it was coming from an area or an approach that was more subjective and more artistic. Mm-hmm. And it was less about the numbers and more about how does it sound. So I was telling them, I designed this space. And actually, I mean, after 5 years working in Barcelona with Arau, I felt that I knew everything, right? It usually happens with people after university. In a couple of years, you think that you know everything, and then you realize that you don't. But anyway, I moved to the States, and then I worked with this firm, and they were like, okay, yeah, that's great that it's 2 seconds, but how is it going to sound? I was like, I don't know what you mean. Right? So one of the consultants at that firm, he was challenging me quite a bit. And he was like, okay, yeah, these numbers are great. And I've been to halls that have the RT, the reverberation time of 2 seconds. And one sounds amazing and the other one sounds mediocre. I mean, can you tell me why? I mean, there must be something else. It's like, and I was like intrigued, right, with the question. So he said, you know what? Why don't you go to this place? So there is this concert hall in Dallas that I am paid it. It's called the Meyerson, and just go and listen to a concert and just tell me what you think. And I thought, okay, listen. I mean, I usually go and measure the hall. What do you mean? Okay, I'll go and see what happens, right? So I did go, and I do the typical thing that acousticians do when they go into a hall. I clap my hands, and it's like, okay, that's interesting. And I started knocking on walls, and it's like, wow, these walls are super heavy. It's like that's.
You sound like an architect. First thing we do is we start touching walls and looking at ceilings.
You take your laser tool out of your pocket
staring at
and
corners
start
of
measuring.
rooms. Yeah.
Yeah. So it was like everything was wrong. It's like it was like the walls were like super heavy. It felt like it was like, I don't know, 24 inches of concrete. In Europe, we used to put some wood in the halls to provide a little bit of low frequency absorption and have a flat response. In that space, I didn't see any wood. I mean, I could see wood on stage, but I didn't see the walls were like super massive. And then I I was looking up, and it's like, wow, where is the ceiling? It's like it's a different zip code. It's like the volume is completely wrong. And then I look over the stage, and they have this thing that is flying over the musicians that it looks like the Enterprise, right? It's like, what is that thing? And anyway, it's like, okay, I bought the ticket. You know what? I'll just sit here and see what happens. At least I'll understand what bad acoustics is, right? So I just sat down and see the orchestra coming in. It was the Dallas Symphony, and you could feel the sound, the energy of the audience just talking before the audience, the musicians came in. It's like, oh, that's interesting. It feels like pretty live. Mm-hmm. And actually, when I was going to that hall, I was like thinking, am I going to be able to understand what good acoustics is? Because I mean, I've always measured acoustics. I don't understand. Okay, whatever. It's like, probably I'll be able to hear something that tells me that it's good or bad. So anyway, I start and I hear this sound of the audience, and it's like, oh, that's kind of live and exciting. Okay, that's not bad. And sit down. The orchestra sits down and starts playing, and after 5 seconds, I have goosebumps. It's like, whoa. And I was like, wow, everything is wrong, but it sounds great, right? So, and at that point, I could see just in front of my eyes, I had this world that acoustics was very simple. They had these very solid foundations with these columns and this roof, and everything was very stable. And I could see everything just collapsing in front of my eyes, and realizing it's like, okay, maybe you don't know everything yet, right? So that was quite something. And I mean, that's the important thing here of the story is like, even though I felt that maybe I couldn't tell I didn't know if I would be able to see or say if it was good acoustics or not, but I knew just immediately that there was something exceptional happening, right? They had this physical reaction to the sound. It's like, wow, everything disappeared, and it was all the sound connected with the musicians on stage, and everything else was gone. And I had this sound that was all over the place, surrounding me, but there was still clarity. I could hear all the details. It was super warm with all those massive walls. You could hear the double basses like in your body. And it was like, I don't know how to describe in words what I'm hearing, but it's like having an exceptional wine. Maybe you don't know about wines, but you're drinking a good wine, and then it's like, wow, I don't know how to describe it. Like a sommelier that will talk about, I can taste raspberries and the oak and the terroir. But when you're drinking a good wine, you know that you are experiencing something exceptional. And the same thing happens with acoustics. You don't need to be an acoustical consultant or an expert to really, when you are in front of something exceptional, you know. No, you may not be able to describe what it is, but you know that something magical is happening.
It's interesting. So none of the previous project that you had worked on in Europe, you were able to experience the acoustic once these were completed?
No, I was just focusing on measuring things. I was measuring the reverberation, and it was perfect. I was measuring the clarity, and it was perfect. And the intelligibility and all these acoustical parameters, and just writing the report, comparing the measure data with the goals. And it was a very scientific thing. It was nothing about just sitting and just listening and deciding if it was good or not. But, I mean, and those halls were really good as well. I mean, they were good halls, but I was just thinking about the numbers. And it's funny because when I was in Europe, we had this project that the musicians were not happy with the sound on stage, and we had this meeting with the orchestra on stage, and we were discussing the sound, and it was like speaking different language, right? We were all speaking the same language, but we were talking about reverberation and clarity and stage support and all these acoustical parameters that acousticians have. And the musicians were like, oh, I'm the first violin and I cannot hear the woodwinds, right? And it's like, yeah, it's great that everything is perfect, but I still cannot hear the woodwinds, right? So,
yeah.
And then you realize that, okay, a combination between the scientific and the subjective is really important, because, I mean, there are things that acousticians calculate and measure that we cannot hear. And there are things that we hear that we don't know how to calculate yet, right? So there is this disconnect with things, right? And my feeling was that in Europe, especially, there was this very academic and scientific approach to acoustics, and in the States there are many different approaches, but they landed in this school of thought that was it was the opposite extreme, right? They were doing some calculations, but it was mostly subjective and based on experience more than on calculations.
Is that is the trend, let's say, in terms of being more scientific or subjective, does that still exist in the United States as being more subjective and Europe being more scientific, or are lines being blurred, or is one becoming more popular than the other?
You can still find acousticians that have these very different approaches. And maybe there was this company in New York called Artec that was the one that designed was the acoustician for the Meyerson and many other halls around the world. And they basically pioneered this approach that was more subjective and looking more at the historic references, looking at the great concert halls from the 20th century or the 19th century and basing the designs on those designs rather than on computer models and creating new things that we didn't know if they would work or not. Artec disappeared a few years ago, so that has been lost a little bit. I mean, you still have many acousticians that come from that world that still keep some of that, but I would say that it's a little bit less extreme as it used to be before.
Interesting.
Yeah.
So getting into the nuts and bolts, because I'm fascinated by all of this, on the scientific method and approach, what other things are you measuring aside from the reverberation time?
Mm-hmm.
Yeah. So go ahead.
Yeah. So what other things? And then also, it sounds like you described that there's a computer model which is used to also test these things before anything gets constructed, and presumably that gives feedback to the architect to tweak things as needed. And so, what are some of the things that are measured? So
the most common acoustical parameters, the first one is the reverberation time, and as I was explaining, this estimates how much time it takes for the sound to disappear when you stop playing a sound, right? So in a cathedral, it may take 10 seconds for the sound to disappear. Mm-hmm. In a recording studio, it takes half a second for the sound to die. And then we have what we call anechoic chambers, that the sound basically disappears immediately. So you don't have any echo, any reverberation. So that's the first one. That's very common. We have another one that it's called early decay time, and it looks at the decay of the sound in the first 10 decibels. So how quickly the sound decays at the beginning when you stop playing a note. So usually you want that decay to be similar to the reverberation time. You have halls that this initial decay is very fast, and then it doesn't sound as reverberant as you assume that it would be. We have another one that it's called clarity. Clarity quantifies how clear the sound is. And then,
how is that measured? Because that sounds like it would be a more of a subjective thing.
So the clarity, when we talk about clarity, it could be also subjective component, right? When, for example, you have an orchestra playing on stage, very fast passage, right, with very quick notes, and if you have a hall that doesn't have enough clarity, all these notes get blurred and you lose some of the details, right? Mm-hmm. That would be the subjective thing. Or pizzicatos, you hear the pizzicatos very well, or you don't, right? So clarity, scientifically, how it's calculated is the sound, when you clap your hands in a hall, the sound bounces around. You initially, if you're sitting in the hall and someone is clapping the hands on stage, you first hear the sound that arrives directly from the hands to your ears. So that's what arrives first. That's the shortest path, right? So you hear that. Then after that, you hear reflections coming from the walls, from the floor, from the ceiling. And at the end, you hear what we call a reverberation, that it's sound bouncing around the room multiple times, not the first reflection, it's multiple reflections, right? So when you clap your hands, what you're doing is you're creating what we call an impulse response, right? You're exciting the room with an impulse that your clap, and then the response is all the energy that gets to the receiver over time. To calculate the clarity, you basically integrate the first 80 milliseconds of sound, and you compare that to the total response. The more energy that arrives in the first 80 milliseconds, the more clear the sound is. The less you get, the less clear the sound is, right? Compared to the total response, right? So you do this ratio. In a cathedral, the late sound, it takes a long time for the sound to disappear, so it has a lot of weight, so you lose clarity because the sound that you get in the first 80 milliseconds compared to the total sound is not a lot. In a recording studio, the sound that arrives to you in the first 80 milliseconds is almost all the sound that you'll get, so you have a lot of clarity, right? So that's another one. Then we have another one that is called definition, that it's a similar concept, but it's used for speech intelligibility. And instead of using the first 80 milliseconds, that's what you use for music, you use the first 50 milliseconds.
Okay. 15?
50, 50.
50, 50, okay.
Yeah. Acoustically, any reflections for a speech that arrive after 50 milliseconds, if they are very loud, you hear those reflections as echoes. So instead of becoming integrated with the direct sound, it becomes like a completely distinct sound, what we call an echo, right? So obviously in a theater you don't want echoes because that will definitely impact your intelligibility, right? So you want most of the energy arriving in the first 50 milliseconds in the theater, and definitely nothing really loud and isolated arriving after 50 milliseconds, because that could be heard as an echo.
So if the orchestra doesn't sound good, we could blame it on the clarity definition. I swear we're playing that passage really cleanly.
I mean, it depends on what you like, right? I like halls that are clear but not too clear, right? You may like halls that the sound is much more transparent and clear, that you hear all the voices very well, and you hear all the different instruments coming from specific areas very well and isolated. I like that clarity, but I also like a more blended sound, that you have this sound, and that's what was happening at the Meyerson, that you had sound enveloping you from all multiple directions. So it was not like perfect clarity, but you had enough clarity, but you had that warmth and envelopment that made it like, imagine like a surround sound in a cinema, right? So you had not just the sound coming from the screen, you had all that sound enveloping you. And personally, in a concert hall, that's the sound that I like. That's not the sound that everybody likes, right? It's like wine. You may like a Chardonnay, I may like a Cabernet Sauvignon, right? And there is nothing wrong with both of them. I mean, I enjoy a Chardonnay as well, or a Sauvignon Blanc, but maybe I tend to the Cabernet, right? So
I like that.
Depends on the day, right?
And so I'm guessing you're measuring these points throughout different areas in the theaters.
Yes.
Or is there like is there always like standard, like 4 quadrants, plus this place and that place in the center that's measured?
Yes. I mean, when I was working in Europe, when we were designing halls, and learned this after the fact, we were thinking like 99% of the time about the audience, right? We were not thinking about the stage, the musicians, the actors. We were thinking about the audience. Okay, how do we make the sound in the audience perfect, right? And when we were measuring typically like multiple points in the audience area. If we had multiple balconies, you measured on the orchestra floor, and then in every balcony you had like several points. If the room was symmetrical, usually you just measured one half of the room, because the sound.
I guess that's true. Yeah, I never thought about that.
Especially if you put the sound source in the middle, right? If you put the sound source off stage on the side, then maybe that's not true anymore, right? It actually is not true anymore. But usually we used to put the speaker in the middle, and then to represent like obviously want a speaker to represent a 100-musician orchestra. It's like an approximation of reality, but anyway, that was the way to do it. And then we measure maybe 20 points throughout the hall, and we used to make an average. And all these acoustical parameters, they change. I mean, the sound on the orchestra floor has some characteristics that are very different from the sound on the upper balconies. I mean, some people really like the sound on the upper balconies because even though you are very far away from the stage, you have a level of clarity that's quite astonishing sometimes, right? And people are confused. It's like, why is that? It's so far away. It's like, it shouldn't, why it's so clear? And then you realize that the ceiling is very close to you, right? So you get that reflection from the ceiling that makes things very clear. If you are sitting on the orchestra floor, typically if you are in the middle of the orchestra floor, that's quite challenging because everything is very far away from you. Even though you think, okay, it's a good location, it's like acoustically it's quite challenging because the side walls are far away, the ceiling is far away, and if you don't get any reflections, it's like listening to music or speech outdoors, and that's not really very good. So
yeah, that's funny because I would have like without any thought at all assumed that being on the I call it first floor level. That's not what it's called probably, but in the middle on the ground level would be like the best spot, but perhaps not.
It depends. I mean, and again, that's a great thing about concert halls, that everyone has a taste and a kind of sound that they like, right? So you can choose the place that in the hall that it's responding to your taste, right? So if you want a sound, personally, I typically sit on the orchestra floor 2/3 closer to the back. I don't like sitting close to the stage. I mean, some people really like seeing the musicians very close. I really
seeing
prefer
their feet.
exactly.
yeah.
Exactly. And seeing the faces, I mean, that's great. I rather sit further away. Maybe the sidelines are not as good, but at that point, closer to I say 2/3 of the back, you get more of the response of the hall. You hear more of the hall, and you have from my point of view, in a good hall, you have like the perfect mix for my taste of clarity and envelopment, and that's what I like. But other people, they feel that sound is maybe has too much going on, and they prefer sound that is more clear, and then they may move to the second balcony or the third balcony to get that sound, or closer to the stage.
Interesting.
Right? So
Interesting.
that's the other misconception. I mean, when you talk about the acoustics of the hall, I mean, there are multiple acoustics in a hall. I mean, there are similarities and things that are consistent throughout, but it changes quite a bit from one place to another.
I had one more question about. Go ahead.
No, go ahead.
I had a question about the computer model.
Okay, ask your question and ask mine after that.
Okay, yeah. How accurate is like the computer model metrics compared to when the calls and theaters were built in real life? And was there ever a time where the discrepancy was really big and then everyone had to think like, okay, how do we retrofit what we just built to fix the numbers?
Yes, actually, we have been using computer models quite recently, so that's quite new. I mean, the formula to calculate the reverberation time, that's from 100 years ago, so it's not that old. So before that, we didn't know how to calculate anything. So that was done by a physicist called Sabin. He was studying he was a professor at Harvard University, and there was a hall that had really terrible acoustics. He spent like countless nights moving cushions back and forth into that hall, and with an organ pipe just generating sounds and then stopping that sound and calculating with a stopwatch how long it took the sound to disappear. And then he got this graphic that was basically the time that it took for the sound to disappear versus the number of cushions in the hall, right? And he realized the more he had, the shorter the reverberation time. And then eventually he realized that there was a relationship between volume, absorption, and reverberation time. And finally we were able to to calculate something and start our scientific approach to acoustics, right? So that's fairly new. And then later on, we started with computer models. Computer models assume that sound is it's like a ray. So it's like a ray that just bounces into a wall, and the angle of incidence is the same angle as the reflection, and then from the wall goes to the ceiling. And then with these computer models, you can calculate an impulse response, and from that impulse response at different locations, you can calculate all the acoustical parameters that I was mentioning before. And as I said, I mean, all these acoustical parameters are great, but they don't describe the acoustical environment perfectly. I mean, they're pretty close to what you actually measure in the hall, but as I said, this doesn't mean that the acoustics are going to be great at the end.
Right.
So you may have the perfect reverberation time, but it may still sound mediocre to you. So it's like, okay, because the sound is actually, it's a wave, right? It's not a ray, right? So that's why sometimes we build scale models, actually, right? 1 to 10 or 1 to 20. And we excite that model with sound waves, and we measure inside that model the impulse response. We have to scale everything, right? So if we are doing a 1 to 10 scale model, so 100 hertz in the real world become 1,000 in the scale model, and you have to scale everything and measure everything. But there are also limitations with the scale models, because how do you scale a seat or a curtain into something in the model, right? So, and you also have the air absorption that absorbs high frequencies very well. So when you go to 4,000 hertz in the model, that doesn't really behave the same way that 400 hertz in reality. So there are always limitations with all these things. They help you figure out how to design the hall and help the architect explore different things. But it's important to use also your intuition. You know that certain things, maybe the model tells you that this is going to work, but your intuition, you have seen other halls that have been done that way and they don't work, and you understand why they don't work, but the computer still says that it works. I remember working with a big engineering firm in the past that young consultants, they've been working all their lives with computer models, and they truly believe the models and the results in the models, and they lack that intuition. It's like, okay, don't you see that this doesn't make any sense? It's like, no, but the computer model is telling me that the reverberation is 3 seconds. It's like, come on, this is very small room. Doesn't make any sense. It cannot be 3 seconds. Yeah, but it is. And then it's like, okay, just let's check the model again. And then you realize that the model is not closed, or there is some kind of... so you have to be careful, right? Computers are great. They're great tools. And we use them all the time. But it's important to have be a little bit critical about things and think if they really make sense.
Do you account also for I'm sure you do, but the number of people in the space? Let's say if it's if you have 10 people versus you have 100 people, and talking about volume in the space, is that a factor as well?
Yes. Yeah. Yes, it is. Actually, and that's one of the things that I learned in Barcelona when I was working with this acoustician, Igineu. In a concert hall, his approach was to find the perfect volume based on the number of seats, right? So audience, we are the most absorbing thing in a concert hall, right? Typically in a concert hall, the walls are all reflective. You may have wood walls, or you can have concrete walls, or whatever. That reflects 99% of the sound. What really absorbs the sound is the audience and the musicians on stage. Everything else just makes the sound bounce around in a concert hall. So yeah, I mean, having 2,000 people in a hall, it means that you really need a very large volume, because that 2,000 seats or people will absorb a lot of sound, and you really need to have a lot of volume to compensate for all that absorption. If you only have 200 people, it's like a recital hall. You don't need as much volume to achieve the same level of liveness and reverberation because you have significantly less absorption. So yeah, the audience is the most, and the seat count is really a critical parameter when we design a hall. And actually, when you go beyond 2,200 seats, 2,500 seats in a concert hall, it becomes really challenging because you need to make the space so large that then surfaces are so far away that you're going to lose the clarity and the impact that you really want in the hall, right? So that's why typically you don't see concert halls that are more than, it's 1,800 seats, 2,200 seats, maybe 2,500 seats, but it's hard to find a good concert hall that goes far beyond that number.
That it's a stadium, right?
So the concert halls that you're describing also are not supplemented with speakers. Like we're talking about raw sound that's coming only from the stage. Yeah.
Yeah. So sometimes people ask me, what's the best acoustics in the world, right? It's like, okay, best acoustics for what, right? That's the first question, right? Because I've been talking a lot about classical music and speech and actors and drama, and all of that typically is unamplified, right? It's natural acoustics, what we call natural acoustics.
Okay.
So and these are the spaces that I really enjoy designing and working with the architects, helping them design this kind of a space. So in these rooms, the walls, the ceilings, all the surfaces are super critical because the instruments, the voice, it doesn't have a lot of energy, and the walls and the ceilings and the floors, they help reinforce that sound and provide the quality, intelligibility that you need in the space, because you don't really have speakers to help you with that, loudspeakers to help you with that, right? So those are really critical spaces where the volume is really important, the shaping is really important to make sure that both the audience and the musicians or the performers on stage, they get the right amount of direct sound and reflection so they can have like a wonderful experience without any amplification. So that's one thing. In a concert hall, as I was saying, you want the space to be a little bit live and create this sound that when you're playing a violin, for example, you feel that the hall is holding you, right? It's not like the sound is just dropping to your feet, and it's really hard to play in that room. When you play a violin in a good concert hall, you have this feeling that the sound is just holding you, right? It's like you feel really supported, or you are singing, you feel that, there is some response to the hall. It's like not singing like outdoors. It's like singing in the shower, right? You have that kind of support, right? that you like. Then for drama, you need less reverberation, and you want more definition and clarity, right? You want the response to the sound to decay more quickly and get a lot of sound to the audience very quickly, so you have a lot of energy before these 50 milliseconds, right? So without any amplification, you can understand every single word in the space, right? I mean, that's less common nowadays. You see a lot of performances in theater that they use wireless microphones and amplification, but that's a different story. So when you use amplification, that's a different story. I mean, usually the hall is your enemy in that case, because you already have the speakers. You can put them in the right places to cover the audience very well, and also the stage very well. So you really don't need the walls. You don't really need the ceiling. Actually, the ceiling is just creating, or the walls are just creating noise and destroying the clarity that you want. So in that case, you want the room to go away, right? You want you don't need the room. It's like it could be a problem. You go into a space that they do like a very loud an arena. They do like a very loud rock concert. Usually the problem is the response of the space, the reflections from the ceiling and the walls. They make the space boomy, and the sound engineers are like, they hate that. It's like, no, just I don't want the room. Just have my subwoofers. If I need more bass, I'll put more subwoofers. If I need more sound, I'll put a larger line array that can create that sound. So the acoustics for that kind of a performance is very different from the acoustics of a concert hall. It's actually the opposite, right? So.
Interesting. Yeah. And now a quick break to thank the sponsors who support the second studio. Revit users, you have access to a powerful new capability you might not know about. Available with Revit version 2023.1 onward, Autodesk Insight is a next-generation carbon analysis tool that can help you make the leap toward low-carbon design. With only a few clicks, Insight lets you analyze, understand, and track the embodied and operational carbon impact of your design choices. You can then visualize opportunities for energy efficiency and carbon mitigation with its flexible dashboards, helping you make more sustainable and informed decisions. Check out the Insight link in our show notes to learn more. This episode of The Second Studio is brought to you by BQE Core, the all-in-one firm management software built for architects. Designed by architects for architects, Core helps you track time effortlessly, manage projects seamlessly, and get paid faster, so you can focus on design, not spreadsheets. With powerful automation and real-time insights, it's everything you need to run a smarter and more profitable firm. See how BQE Core can transform your practice by clicking the link in our show notes.
I'm very curious about the more subjective method that you were describing before. Like, if the first one is more measured and based on computer models, how does this more subjective methods work if you don't rely on that?
Yeah, and how do you plan?
Like, do you join the project when the room is already built and you kind of like put cushions here and there, like make it that way? Like, what's the process?
You have to redesign the room. I'm sorry, it doesn't sound good.
No, with a subjective approach, basically, I mean, you can actually apply that methodology once you have enough experience and you have been to many halls and many theaters in the world, and you really start to understand what's the relationship between architecture and sound, right? I mean, now, after all these years, when I go into a hall, before even I hear someone speaking or an orchestra playing, I imagine how it's going to sound, just looking at the architecture, right? Mm-hmm. So when you do this more subjective approach, that's how you help the architect to design the hall. You basically base all your recommendations in your experiences, and you know what works, what doesn't work. You know that the shoebox hall creates a sound that is very enveloping with a very high density of reflections that make the sound really full. And if you have a fan-shaped room, you know that kind of room pushes the sound towards the back, and it sounds like very frontal in your face. It's not enveloping, but that's a good sound, for example, for a venue, for amplified sound. And you make your recommendations based on your experience. Obviously, when you start, you don't have that experience, and many acousticians, if they follow the scientific approach, they don't have spent the time listening to the sound and developing that subjective knowledge, right? That mm-hmm. would allow them. Everything needs to be based on a model that you do. I mean, actually, after all these years, I think that the combination between both is the ideal world, right? I think that the problem with the subjective approach is that the person that started that approach, Russell Johnson, he probably had like a very solid, I didn't work with him, but he probably had a very solid knowledge about physics and acoustics. And he actually had worked with other consultants before that were using that kind of very scientific approach. So he knew that. And then he started the subjective approach, and all the recommendations that he was making and all the things that he was learning along the way, I'm sure that it was very logic and it had it made a lot of sense. But some of those recommendations were passed to other consultants that were working with him, that maybe they didn't understand where that recommendation was coming from, right? So, and in my experience, we ended up with the most extreme of the recommendations, right? At the end, the consultants were recommending we need like a 24-inch wall, and it needs to be heavy concrete, otherwise it's going to be a disaster. And the question is like, why 24? 18 is going to sound bad? Is it going? I mean, I'm sure that that 24-inch recommendation, Russell Johnson made that recommendation for a hall that maybe the conductor really felt really strongly about the sub bass and having like the 30 hertz really resonate in a special way. But some of those recommendations, I had the feeling that they were lost. The knowledge of why they were important, they were lost. So I think it's important that you don't forget about the physics, and there is some correlation between the subjective and the objective approach.
It's interesting because as you're speaking, I'm thinking about the parallels that exist between what you've said and what happens in our profession of architecture, because it is known as being this profession that has to balance the more objective engineering, scientific kind of approach, versus being artistic and creative, and these kinds of generic words. And it is both things for sure. And I think that sometimes for some architects or younger architects, it's like, to your earlier point, it's easy to rely on clearly quantifiable data and metrics and calculations and things, and checklists of things to secure yourself and say, okay, I've done all that stuff. I've done items 1 through 10. It must be a good design. And of course, in architecture, that's not how it works. You could do 1 through 10, or if the list is 100 things, you could do all the 100 things correct, but it doesn't necessarily mean that the cake is good because you have all the ingredients there. So it's really interesting to hear you describe all of these things.
Yeah, I'm just thinking about that, and just going back to the computer modeling. We design all these halls in the 60s, 70s, 80s, 90s. I mean, with all this technology that got better and better, and we tried all these different things using models and different parameters, and we failed miserably. So we learned a lot as acoustical consultants during that period of time. For example, we have the Philharmonic Hall in New York that was built in the 60s, and it was like a big failure. And it had the best acoustician in the world working that project. And through that process, we learned that certain things that we thought that were true were not true, actually. I mean, it was like a pretty expensive lesson. But, and I mean, Beranek, that's the person that did that hall, or that was consulting for that. I mean, he spent many years touring around the world, talking to musicians, and he wrote this fantastic book about concert halls and opera houses, where he has like drawings of all these halls and all this information about volume, number of seats, we were discussing before, comments from the conductors and musicians in these halls. And after all this process, he developed like a guideline that said, okay, let's do, as you were saying, let's do like, get all these things right, and let's do an average at the end. And if the average is high enough, it's going to be good acoustics. And we learned that that's not true. I mean, the average doesn't work for acoustics, especially for these halls that we really want exceptional. For exceptional, everything needs to be perfect, right? So if you have like 90% right and 10% wrong, it could be like a complete disaster, right? So, and when I work in these halls, I'm really hands-on. It's not just overseeing the project. It's because, I mean, maybe if we get 80% right, it's going to be good acoustics, but good acoustics is not good enough, right? If you get 90%, it's going to be excellent acoustics, okay? But still, that's not good enough, right? So if you get to 95 to 100%, then it's when you get to exceptional acoustics. And it's like every single detail. It's like sometimes, I guess, probably architects, they feel that, okay, these guys are really obsessed about every single detail, and they don't let go. I mean, even this little thing they keep pushing for, they got that, but they still push for something else, right? It's like, and some consultants talk about this creative tension, right? It's like, okay, I want all the acoustical things to be perfect. And I understand that the architect has other priorities that maybe are not completely aligned with what the acoustical consultants are trying to achieve. And it's important that we both achieve perfection,
Sure.
right? And we,
Especially in a concert hall, yeah.
yes,
I mean, one could argue that your outcome is more important than what the thing looks like. So when you work
not really. No, I mean,
No?
it's there is this concert hall in Barcelona. It's called Palau de la Música Catalana, the Palace of the Catalan Music, if we translate that from Catalan to English, right? And it's this beautiful, they call it modernism in Catalonia. It's like Art Deco, right? It's this hall that has all this stained glass, all this natural light. It was built for a local choir, and they used they did fundraising in the community, and they felt like, okay, we need more seats, and they ended up putting more seats than the volume that they had in the hall. So the room is not very reverberant. It has a good sound, but it's not the music Vereinssaal in Vienna, for example. But it's such a beautiful place that I remember, I mean, when I was living in Barcelona, and I used to go on a Sunday morning to that hall to hear an orchestra. It was like, I mean, I'm going to say something that I'm going to regret. It's like, who cares about the acoustics, right? It's so beautiful. It's like,
right.
it's like it was like something exceptional, right? It's like what I was saying about the wine before. It's like you feel that there was something, that light filtering through the windows, and that all the audience, that all the faces, is like, okay, the acoustics got you to maybe 80%, but then the architecture made the experience got to the level of exceptional, right? So
if we ever work together, I'm going to recite this story to you.
I'm going to keep pushing for 100% perfect, right?
That's a beautiful story.
I was wondering if you think the fact that you are a musician makes you, I don't know, understand or makes your perception of acoustic a lot more enhanced, yeah.
And as I said, not really. I mean, you have many acousticians that have similar backgrounds right? That you have a combination of engineering and music, architecture and music. You have some conductors that love architecture as well that are also acousticians. So you usually have this mix, right? So, but I think that, I mean, I've been with acousticians that, I mean, they don't listen to the sound in the hall. It's like they just think about numbers, right? And people that are not acousticians and not musicians that really think about sound in a very interesting way, and they'll use a completely different terminology than the one that I use, but it's very interesting how the insight that they have on sound, and yeah. So I don't think that, I mean, it's being a musician and having that understanding definitely brings something else to the mix, but I mean, I don't think that's the absolute thing that you need to really understand sound.
So when you're working with architects and for a concert hall, how does that, I'm curious about the entire process. So maybe actually starting from the beginning, when you're meeting with the architect, actually maybe more so the client, and you're setting up goals and preferences and a direction for what the sound should feel like or sound like. How does that conversation go? Does the client have, because it's hard to, like, we face the same thing in our profession, right? Which is more visual than it is about sound, but it's hard to use words and understand what those words mean from one person to another. So in our case, someone says, I like modern. Like, okay, well, what the heck does that mean? Because it means 100 different things, you know, or I don't know if someone's saying, I like, you know, warm sounding acoustics. Well, what does that mean exactly?
Yes. So usually in the beginning of a project, you have like three key players: that theater or a concert hall. You have an architect, you have a theater consultant, and you have an acoustician, right? An acoustical consultant. And the first thing that I would say is, first we need to understand exactly what the client or the orchestra or the theater company, what kind of space they are trying to get, right? What kind of sound they want. And as you said, this is quite difficult to have that conversation, because we use these different words, and maybe we don't have the same experiences. So sometimes what we do is we we tour and we visit different venues, so we can develop this common language, right? Because I think that that's very important. It's like, are we doing a Chardonnay or are we doing a Cabernet Sauvignon here? Because it's really important that we know what we are doing, right? Because otherwise, I may design the hall that with the sound that I like, but that may not be the sound that my client wants, right? So that's the important thing, that we need to get on the same page at the beginning. And we have done some tours with some clients that we just, I don't know, we go with, what are the best concert halls? I mean, the funny thing is the best concert halls, at least the ones that we agree as acoustical consultants are the best halls, they were done before we had any computer models and any technology. So that's kind of a sad, right? But anyway, that's what, or at least the ones that remain. Maybe the bad ones, they are gone, right? Because they were so bad, they demolished them, right? But the good ones, like we have three that we always mention, right? The Music Verein, the Concertgebouw. The Music Verein is the one in Vienna where they do the New Year's concert with the Vienna Philharmonic. The Concertgebouw is the concert hall in Amsterdam. And then the Symphony Hall in Boston, right? These are the top three when we talk about concert halls. And it's like, okay, and they sound very different. I mean, the Music Verein is relatively small compared to the other two. The Concertgebouw is significantly wider than the others. And Boston, it's a shoebox, but it's the musicians, if you remember the Boston Symphony Hall, they play behind kind of a proscenium. There is like a kind of a shell. They are kind of they are not surrounded by the audience. So we can go to these halls and understand, okay, this is Concertgebouw. When we talk about the Concertgebouw, this is what we talk about. We talk about this big, majestic sound that sounds fantastic for Mahler, for this kind of music, but maybe doesn't have the clarity that you'll have, that you would like to have for a classical performance. It still sounds very good, but it's maybe not the best option. Then you go to Vienna, and then it's like just very a good song for classical music. The classical period is like this very rich and very loud and very present, reverberant sound. And then you go to Boston, and it's kind of it's funny. After I mentioned the story about Dallas, right? And I love that hall. It's like, okay, wow, I can hear the flute coming from my left side, and I can hear the oboe coming from the right side. And I mean, I love that the first time that I heard that. But then I went to Boston, because after hearing that hall, it's like, okay, we always talk about Boston, Vienna, and Amsterdam, and I have never been to these halls to hear a concert, so I have to go and see how they sound, because if I'm talking about this is the sound that I want, I need to know what I'm talking about, right? So when I went to Boston has this sound that it's reverberant, it's enveloping, but the flute stays on stage, and the oboe is on stage, still enveloping, but it's subtle. It's just the right amount of envelopment. So it's just very, very, very subtle. I still like Dallas, but Dallas is like it's on steroids, right? You have like the extreme, it's like super, super extreme, right? So it's like, okay, maybe I like that, but I like musicians to stay on stage and not have like things just flying around, moving around my head, right? So that's that. So doing these tours with clients allow them to see the architecture, see the sidelines, experience a concert. And obviously the concert that you hear in Vienna, it's going to be different orchestra, different program than the one that you hear in Amsterdam. But you'll have a sense when we talk after the concert about what we experience, the kind of things that I'm talking about become much more clear. And it may be like, Jaume, yeah, that's great that you like this sound, but we find that this is too doesn't have enough clarity, or it's maybe too bright or too loud or whatever. So that's very important when you can do that kind of a trip and tour and visit all these places and develop this common language with the architect, theory consultant, and also see the implications of sidelines, right? You have a space that has very steep sidelines. You'll see things very well. You may feel very close to the architecture, but the sound also changes. All of a sudden, things become less enveloping and more clear. It's like the sound that's the sound that you want. You have all these vineyard style halls that are becoming very common and very popular throughout the world. They have a very particular sound. So is this the sound that you like, and the sound that will serve your orchestra very well? And if that's the one that does that, then it's the kind of the hall that you need to design. I think about acouστicians a little bit like or about myself a little bit like an instrument maker. Now, right? The hall is the instrument now, and I'm working with the architect to make this instrument create that sound that we talk to the client at the beginning, and that you cannot do that with a computer model. I mean, you really need to think about, okay, you need these reflections that are coming from the balconies or from the ceiling, and the shapes that you need to develop, and you need things to not look acoustical. I think they need to be beautiful as well, right? When you go into a hall and it's like, what are all those things? I think that's bad. I mean, you can develop things that are beautiful and sound great, right? And that's an important thing. That it's not easy, and as I said, you need that tension, right? I'll be saying, okay, I need these things, and the architect's like, okay, can we do it that way? It's like, oh, maybe not that way, but maybe we can explore these, and eventually you figure it out, right?
What so when it comes to the architecture, I guess like kind of the shell of the concert hall on the interior, how does it typically work out? I mean, I would guess there's a fundamental understanding of roughly the shape of the space, and the architect does whatever they're doing, and they show it to you and say, okay, well, I've designed these walls and ceilings, and they're all a bunch of wavy metal panel, I don't know, or whatever they do. And then there's that feedback loop, and you say, well, maybe we have to shift some things around. Like, how does that collaboration go? So
the first firm that I work with in Barcelona, the professor at the university, they had this kind of approach, right? The architect developed the concept, and then we were modeling that and fixing that, right? Let's put some absorption over here. Let's try to angle this wall a little bit. And my conclusion is that doesn't work. I mean, you can fix problems, but it's not going to sound great. You may fix things that are going to be really bad, but you are not going to get to exceptional. The second acquisition I work with, and then after that, I would say that most of the ones that I work with before starting on my own have a different approach. It's like they really start drawing. If it's a concert hall, for example, where it's really critical, they say, okay, that's a seat count. We need this volume. Depending on the sound that the client wants, this is the kind of shape that we should be exploring, and we should be thinking about one balcony or two balconies wrapping around to have the right level of clarity to the sound. And we work with the theater consulting developing these drawings or sketches that then help the architect evolve from that into a final design. And we always design the buildings inside out, right? You design the hall first, and then you design the lobbies and the circulations and everything else. You don't design the outside and then you adjust the levels so they match the lobby. No, it's the other way around, right? You need to get the balconies at the right height. You need to get the sidelines to work. You need to get the stage at the right elevation. And that will define where the lobby needs to be and where the back of house needs to be. So there is a lot of collaboration between theater consultant, acoustical consultant, and architect, right, in this process at the beginning. And then once we get the right concept or like an approximate idea, then these obviously we still have to work through schematic design development and see this to finalize it and tweak it and adjust it. But I think that's the right approach. It's like a collaborative approach. And as I said, everyone is pushing or pulling in different directions, right? So with different priorities.
Interesting. Yeah. So actually, you're almost the first one to set down some parameters for the architect, which would make sense because I guess otherwise where would you start as an architect? I mean, obviously you'd have experience doing theaters probably, but still. I'm curious to know, well, this is my question, which I don't think is the right one, but like, is it more important, is the shape of the space and the angle and the shape of the walls and the ceilings, the form of it, more important than the materiality of it? Or are they both equal, or can one overcome the other? Like if you have a space and the walls are at the wrong angles or the panels are at the wrong angles, can you treat it and use different materials or put bass traps with the little holes and things to fix it? Or what is the balance between those two?
Yeah, hopefully we don't have to fix it. So,
True.
yes. So, I mean, all of the above. I mean, shape is fundamental. Volume, the size of the space is fundamental. Depending on what you want to do, you need more or less volume. For a theater, for a drama, you need less volume than for classical music. And we should talk at some point about multipurpose rooms, because I mean, past century we were doing rooms that were just dedicated to classical music, rooms that were dedicated to opera, rooms that were dedicated to drama. Nowadays, this is becoming less and less common, and we have a lot of multi-purpose rooms. So we should talk about that at some point. But additionally to the volume, then finally you have the materials. And as I was explaining, usually in a concert hall, you don't want to add any more absorption than the audience, right? So you want to keep all the reflections to make the sound, the natural sound, bounce around and create that mix that makes it magical, right? If you start putting absorption, that's taking away some of those reflections. So ideally, you don't want to do that, right? You just want, the only absorption that you have to have, there is no other way around, is the audience. I mean, and the musicians. I mean, that is a given. But the rest, I mean, it should just preserve all the sound and give you all the reflections. In a theater, is similar. I mean, it's probably a smaller volume, and if the volume is a little bit too big, you may need to add a little bit of absorption to compensate for that. But you still want the shaping to be really efficient, sending sound quickly to the audience and also to the performers, so the audience can understand everything very well without amplification, and the performers get a sense of if they're speaking too loud or too quiet, or they have a sense of the response of the room as well.
Yeah.
So all these three things are critical. Shape, super critical. Volume, super critical, especially in concert halls. That you really, if you don't have enough volume, then the room is not going to be responsive enough. And then finally, the materials, that in some cases it's just everything is reflective except the audience. And in other cases, for example, in amplified, in an arena, the shape is also very important. If you have that's usually the case. If you have a big dome over the arena, that tends to focus the low frequencies down into the audience. So you need to put a lot of bass traps and sound absorbers on the upper volume to make the sound at low frequencies clear. Otherwise, it just sounds like boomy, and you lose all the speech and everything else, because you have all these low frequencies just bouncing around all over the place, and it makes it really bad. So in those kind of spaces, I would say that the volume sometimes is a given. There is nothing we can do about it. It's like 8,000 seats or 10,000 seats, so that will push the roof at too high to be good acoustically, and then you really need to work with absorption to try to deal with that excessive volume.
Interesting. I have a very specific question, which is it common, normal for musicians of an orchestra on stage when they're performing not to be able to hear each other very well? And I'm asking specifically because I experienced that actually at the Walt Disney Concert Hall. I played, an instrument for a period of time. I'm not a musician. I haven't played in a lot of places, so my experience is limited. But I have played in a fair amount of venues, having said that. But what struck me about that concert hall from the perspective of a performer in an orchestra was that I could not hear my counterpart to my left or the right from me nearly as well as like the practice room or other places, and it was jarring. It was actually frightening, right? Because of course, when you're in an orchestra, you expect the support from the rest of the orchestra with you, but when you can't hear them, it feels like you're playing by yourself, and then you start to wonder, am I
the only one playing?
am I off by like a measure? What is happening here? But anyway, so is that like a common thing, or is that an anomaly?
No, I would say it's very common. Stages
interesting.
are a really particular case of acoustics, and as I was mentioning before, when I was working in Barcelona, we were just focusing a lot with the audience and not thinking about the stage a lot. You need to keep sound. Some of the sound needs to go to the audience to provide the clarity and the impact and all of that. But you need to keep some reflections back for the musicians to be able to have the cross-stage communication and allow the first violin to hear the cellos on the other side, or the woodwinds further back. Usually you don't have problems with percussion and brass. You always hear them very well, right? And it's not a matter of sound level, because I mean, when we had this hall that musicians were complaining about in Europe, we were measuring on stage. We were sitting next to one of the musicians that he was saying, I cannot hear myself, right? And we put the microphone next to the violin, and we were measuring 85 decibels. And he's like, what do you mean you cannot hear yourself, right?
Right.
And that could mean many things. And for example, in a stage, you really want reflections from the other side of the stage to come to you relatively quickly and loud enough so you hear musicians that are far away on the other side of the stage, cross communication, right? You don't want the sound that you're producing to be too loud, because if it's too loud, then you don't hear musicians that are too far away, right? Because that's masking whatever it's coming later. And at the same time, you want to hear some sound coming back from the hall. If you don't get any sound coming back from the hall, and that's very common, that happens in many halls, you don't know what the audience is hearing. You don't hear the mix of the orchestra sound, right? And I mean, if you are the Vienna Philharmonic and you have these amazing musicians, I mean, they don't care. I mean, they can play even in the middle of Central Park without any reflections, right? They are brave enough to. They don't hear the oboe that just plays one measure before you are supposed to start, but they just play right where they are supposed to play. But usually that's not the case, and you really rely on what you hear and the other sections of the orchestra. Not just looking at the conductor when the conductor tells you to just jump in. I mean, it's really scary when you don't hear things that you're supposed to hear, right? It's like, okay, you need to really, really be sure of yourself. It's like, okay, now. But big time. So yeah, the acoustics of the stage are really critical. I mean, there's a misconception with musicians that you really want the ceiling really low, right? I see many halls that they install these canopies and they lower the ceiling a lot, and they have the feeling that will help them hear themselves. That's actually not true. I mean,
Really?
What happens when you do that is that you usually hear yourselves quite well, because you have this very strong reflection, but you don't hear anything else, because that's so loud that then you don't hear the musicians that are further away. You don't hear the hall, because that reflection is so weak in level that the initial reflection is so loud that that's the only thing that you hear. So I know it's scary, but the ceiling needs to go up. Yeah, and I've done these tuning exercises with orchestras that, and we can talk about tuning as well, that you actually adjust the architecture to get the right balance on stage and in the audience, right? And you change the architecture when you can change, for example, canopies, or you have surfaces around the stage that you can move or change the angles to really get to that balance and achieve those levels of cross communication that allow the orchestra to hear themselves very well. And I think that's very critical. If the orchestra cannot hear very well, then the performance is going to suffer, because you are not going to be playing at ease, you're going to be in tension all the way through.
Yeah.
And maybe the tension is good sometimes, but it's if you are scared all the time, that's also you can hear that in the sound. So.
Yeah, I agree with that. I mean, there's definitely a level of, well, look just how good you are, and your confidence. But then there is definitely a gap. Like, what did you say? You said like, there's relying on yourself as a performer, and obviously you're staring at the conductor, which is a visual thing.
Yeah.
But then there's a gap between those things and then what you're hearing in the orchestra, and I feel like there's definitely very, very micro adjustments that are always being made when you're feeling yourselves as a group. And when you don't hear the other musician, it's a strange, because now you're missing the third or a piece of that feedback. It's a very strange experience.
Yeah. For example, in a shoebox, I was talking about shoebox. Shoeboxes are kind of the traditional style of concert halls of the past, right? That they usually get this sound that is very blended because they have a lot of reflections back and forth. So you tend not to hear every single voice. You hear more. I mean, you hear the voices, but they are more blended. Mm-hmm. In a hall like Disney or Vineyard style, things are much more transparent. You hear every single voice, every single instrument, right? And some musicians describe that as being naked, right? That it's like you are really exposed, right? There is nowhere to. The sound doesn't hide any of the errors. You need to be very precise and very perfect, and obviously that. The result is like a very special sound if you can really be that precise. The shoeboxes are a little bit more forgiving, right? Because that all those reflections hide some of the errors and make things a little less obvious, and you feel a little less naked and a little bit more protected in the hall, right? But that may not be the sound that you like. You may like more the sound that it's more people that have like very good sound systems. They talk about very transparent, right? The sound that is very transparent, that it's very clear, that there is no messing around. It's like just
right.
What you hear is what you get, right?
Yeah. Well, I can say as a B- level musician, I prefer the sound to be mixed. So I am not naked. I don't want people hearing me. You want to talk about multi-purpose rooms, and I know we're coming up on the hour here, but are they much more difficult to design than when the objective is just a singular purpose of more singular, like a hall?
I mean, yes, they are. They are because, as I said, the acoustics that you need for, let's say, the typical multi-purpose room needs to do the following. Let's start with the extreme classical music. And amplify classical music. Then they typically want to do opera as well. It's a little bit less reverberant, and there is a little bit of singing, so some speech intelligibility needed. Again, no amplification. Drama. And usually multipurpose halls, there is some amplification, but you may want the space to be responsive enough that you can do some speech without amplification. So that's next. Then usually you want to do conferences and things that are amplified. And then you want to bring touring events that do like loud amplified events in that space, or even you may want to do some cinema as well, right? So we're going from a room that needs to be very live and reverberant for classical music to a room that needs to be very controlled for loud amplified sound for a band playing on stage. And when I was designing these kind of rooms in Barcelona, we used to do like an average, like, okay, for classical music you need 2 seconds, and for speech, let's say that you need 1 second, so let's design something that is 1.5, right? And that was basically bad for everything, right? So
just a compromise.
Not bad, but was not the best, right? It was like a middle ground. It was like it worked. It was like kind of the lower range for classical music, but it was not the best. And for speech, it was a little bit. It was still intelligible, but it was a little bit too reverberant. Currently the multipurpose halls, they have a lot of adjustability. We have all halls that the basic thing is that you may have curtains or banners or elements that deploy when you need some absorption, right? That for classical music, you may have all the walls being sound reflective, and then when you do something that is amplified, then you have all these elements that appear in front of the walls and cover all the surfaces with softwoods and around the stage as well, to provide that level of control. So that's one level of adjustability. There are halls that have adjustable volume. So you design the volume for opera, but then they have like additional volumes next to the concert hall with big doors that you can open. So when you do classical music, you just open those doors and you add additional volume to the space. So you increase the volume to the space, so it works great for classical music. And when you close the doors, then it's perfect for opera. And then you start adding some absorption for speech, and then you add a lot of absorption for amplified events. So that's what we do. We design halls that the architecture changes significantly to be able to accommodate this broad range of users. It's quite challenging. I mean, it's definitely easier to design a pure concert hall than designing a multi-purpose room that sounds great for all these things. But we are doing great halls that for example, we designed a hall in Mexico, in León, and one in Bogota that are they're multi-purpose rooms, but they're currently being known as the best concert halls in those countries, in Mexico and Colombia. So you can do multi-purpose rooms that sound great. And in a multi-purpose room, in a concert hall, there is no stage house. The musicians and the audience are in the same volume. In a multi-purpose room, there is always a proscenium. There is a stage house, so you can have theatrical performances and opera performances. And that's not what a concert hall typically is, right? So you need to add acoustical shells and elements to enclose the musicians in the stage when they're on stage, so the sound doesn't get lost in the stage house. So they're pretty complex spaces.
Fascinating.
All right, we're coming up on time. Our last question, which is kind of a little tradition, is what is your favorite building? And I guess in your case, maybe what is your favorite hall? It's a difficult question.
I mentioned the Palau de la Música, and I'm Catalan, so I'll be going home here, and that's a beautiful space that I remember those concerts from 30 years ago, right? It's like, wow, they still remain in my head. So that's a very special place that I like. Buildings, so many buildings. I mean, one of the spaces that I really enjoying in New York, I don't know if you know it, it's called Park Avenue Armory. It's this big armory space. And it's a beautiful, they have this real hall with this beautiful structure, all these beautiful trusses, and they do all these very experimental events in that venue, and it's like a quite interesting building from another century that's still working very well in the 21st century. So that could be a good one.
That's a good one.
Yeah, I like that. I like that. Jaume, thank you so much for joining us. This was really, really interesting. I appreciate you answering all of my silly specific questions and some of the big ones as well. This was great.
Thank you.
My pleasure. Thanks for having me.
Thanks, everyone, for listening to this week's episode. If you want to support the show, then one great way to do that is to leave a review of it in the Apple Podcast app. You can also find us on Spotify and YouTube. We have a website, which is secondstudiopod.com. Instagram is also Second Studio Pod, so give us a follow on there. And if you have guest suggestions, comments, questions, I don't know, if you're looking for marital advice, whatever you want, you could text.
So if you have some good jokes you want to share, I'm still waiting for some.
Reach out through our hotline, which is 213-222-6950. You can call it and it'll go to voicemail, I think, or or you can send a text message to it.
Yeah,
right?
yeah.
I'm hungry. Okay, that's it. Talk to you soon, and thanks for listening. Bye.
Bye-bye.